The first thing we have to do is to even the triangles with the main formula, which is AB by DE is equal to AC by DC is equal to BC by EC. Then we replace those with our data. So AB is 8 by DE, which is our x. We don't have values for AC, DC, so we delete them. Then we equal that with BC is 27 because we sum 12 plus 15 by EC, which is 15. Then we divide 27 by 15, so 8 by x equals 1.8. And finally, we clear up x and we have x equals 8 by 1.8, which gives us 4.44 as a result.
We are gonna we have c squared equal to a squared plus b squared. Then you're gonna replace 13 squared plus 10 squared, and 13 squared is equal to 169, and 10 squared is equal to 100. So then you have 169 plus 100 equal to 269, and you're gonna you pass the square to the other side as a root, and it gives you 16.40.
36, and this is equal to 3,812 minus the result of 1,456 by 0.78 of the angle, and by 2, that is equal to 2,271.36. Then we have to take away. A squared is equal to 3,812 minus 2,271.36 equals 1,540.64. Then we clear the a by changing the square to the other side of the equal sign, and now is a the square root of 1,540.64. Then is the square root of a is equal to 39.25. With this we have the first side, and now we have to find the angle B. The formula is B over sinus of the angle B equals A over sinus of 38. So it will be 26 over sinus B equals 39.25 over 0.61. If we make this formula, we will have the result of 23.82, and this will be our angle B.
In this problem, we have that A and B are equal to x, C is equal to 120, side A is equal to 18.5, side B is equal to 28, and side C is equal to x. First, you need to get side C with the formula c squared is equal to a squared plus b squared minus 2 times a times b times cos c. We start by replacing c squared, which is equal to 342.25, which is the result of the multiplication a times a plus 784, which is b times b. That result minus 2 times 18.5 times 28, which is 8 times b times cos c. We continue adding c squared, which is 342.25 plus 784, which is a plus b, which is equal to 1,126.25 plus the multiplication of 18.5 times 28 times 2 times cos c, which gives us 518. So we have that c squared is equal to 1126.25 plus 518, which is equal to c squared is equal to 1644.25. We need to get the root of that, so what we need to do is pass the square to the other side like a root, so a square root of 1644.25, so c is equal to 40. So you get side b with the formula side c dividing sin c, which is equal to side b dividing sin b. We start replacing, so c is equal to 40 and sin c is equal to 0.86, so side b is equal to 28 dividing sin b, which we don't know the result yet. So you divide 40 by 0.86, which is equal to 46.5, which is equal to 28 by sin b. You pass the 28 to the other side to leave sin b, so we have that sin b is equal to 28 by 46.5 by sin b, which is equal to 0.60. You pass sin to the other side to leave the angle b alone, and you have that b is equal to sin minus 1 times 0.60, which is equal to b, which is equal to 36.8. Now you need to get angle A the same way that the last problem, which is by using the formula A plus B plus C, which is equal to 180. So you get that A plus 36.8 plus 120 is equal to 180. So A plus 156.8 is equal to 180. So you pass that 156.8 to the other side by subtracting it, and you get that A is equal to 180 minus 156.8, which is A. So A is equal to 23.2. So now that it's done, we have that A is equal to 23.2, B is equal to 36.8, and C is equal to 40.
So we have different applications of the theorem of Pythagoras and the theorem of Thales. In the theorem of Pythagoras, let's say two friends are meeting at the playground. Mary is already at the park, but her friend Bob needs to get there taking the shortest path possible. Bob has two ways he can go. He can follow the roads getting to the park, first heading south 3 miles, then heading west 4 miles. The total distance covered following the roads will be 7 miles. The other way he can get there is by cutting through some open fields and walk directly to the park. This could be one example of an application of the theorem of Pythagoras. Thales' theorem can be also used to find the center of a circle using an object with a right angle, such as the set square or sheet of a paper larger than the circle.